solve systems of equations that are written in two variables. There are options for solving these. You can do it either by substitution, elimination, or by graphing the two equations and finding the point where they intersect. Because in my experience, most students have favored elimination. That's what I'm going to use, but you do have those other two options if you've learned it that way and prefer that way. So our goal here is to solve for x and y, but you can see that each equation has an x and a y in it, which makes it difficult to solve. So what we're going to do is use both equations, and to use elimination, what you want to do is choose either x or y that you would like to completely eliminate from the problem for now. Okay, and so if I were to look at this, maybe I would say, okay, I want to eliminate x. And so what you're looking for is for the x's, if you've chosen to eliminate that, you want to end up with the same coefficient in front. Okay, so here I have negative 2x, except you want the opposite sign. So I want somehow to have a 2 here, because if this is 2 and the other is negative 2, when I add them, they will cancel, because I'll have 0 x's left. So what we do is we multiply this entire equation by positive 2. As long as I multiply the whole thing, I'm not breaking any mathematical rules, because I'm multiplying both sides of the equation by the same number. So when I do that, I get 2x plus 2y equals negative 6. Do not forget to multiply this number on the other side, or it will mess you up awfully bad. Okay, so let's write down the other equation the way it was originally. We haven't done anything to it. I'm just going to move it over here so that I can add them. So here I have negative 2x plus y equals 12, and I'm going to add those two equations together. So notice negative 2x plus 2x is 0x. For my y's, y plus 2y gives me 3y. And for the constants on the other side of the equation, 12 minus 6 gives me 6. Now I have one variable, and I can actually solve this. I have 3y equals 6, so I just go ahead and solve that equation. 3 times y, so to solve, I do the opposite and divide both sides by 3. And I get that y is 2. Now I'm not done, because I have to solve for both variables. Once you've solved for the first variable, you go back to your original equation and take either of the equations that were there, this one for example, x plus y equals negative 3, and you substitute the value you found. Now we found that y was 2, so I'm going to replace the y with a 2, write everything else exactly the same, so I have x plus 2 instead of y equals negative 3. And I solve that equation for x. So I'm going to subtract 2 from both sides, and I get the solution, x equals negative 5. Now you'll notice when you write your answers, they'll want it to be in coordinate form. So remember, coordinates are written x comma y. So my solution here would be negative 5 comma 2. This is the point x, y. If we were to graph these two equations on an xy coordinate plane, they would intersect at the point negative 5, 2. Okay, let's try a couple more. Here's another example. I have 2x minus y equals 1 and x plus 2y equals negative 7. So my first job is to select which variable I want to eliminate. Let's say I decide to eliminate the y's this time. Well, notice I have 2y here and just a negative 1 here. So for somehow I need to have 2, and I need to make this one be negative 2 instead of negative 1. I can accomplish that by multiplying this equation, this top equation, by positive 2. Okay, we don't have to do it by negative 2. We already have opposite signs. We just need to change the number that's there. If I do that, I get 2 times 2 is 4x, 2 times negative 1 is a negative 2y, and 2 times 1 is 2. Again, don't forget that number on the opposite side. This other equation, I'm not going to change it at all, because I was able to get the same number by just multiplying one of the equations. We add those together, so here 4x plus x gives me 5x. Negative 2 plus 2y gives me 0y. That's what I was going for, so it's good that that happened. And 2 plus negative 7 gives me negative 5. Now I have an equation with just one variable, x, and I can solve it. I divide both sides by 5, and I find that x is equal to negative 1. Now that I have x is equal to negative 1, I go back to my original problem, select either of these equations. Okay, let's say I took the top equation instead this time, which was 2x minus y equals 1, and substitute the value that I found for x. So I'm not going to change anything except for the x, so I'll have 2 times negative 1 instead of x, minus y equals 1. 2 times negative 1 gives me negative 2, and I solve the equation for y. So I add 2 to both sides, and I get negative y equals 3. And last step, divide both sides by negative 1, so that I have that positive y is negative 3. So my solution is that x is negative 1 and y is negative 3. I want to write that as a coordinate x comma y, so I get the answer negative 1, negative 3. And I'm done. Okay, I'm going to do one more example. This one's a little different, adds one more element of complexity to it. If we select a variable we'd like to eliminate, x or y in this case, we can't just multiply one of the equations by a number, okay, because there's no way we can take 4 times a number to equal 5, a whole number, or 3 times a whole number to equal 2, or 2 to equal 3. So we're going to have to multiply both equations by something in order to make this one work. So again, your first step is to select which variable you would like to eliminate. So let's say I decided to eliminate the x's. So I need the number in front of x to be the same number, but with opposite signs. So if I take this top equation times a positive 5, and the bottom equation times a 4, it's kind of like finding the least common denominator for a fraction. Notice I'll get positive 20 here and negative 20 here, and that will cancel my x values, and I'll be good to go. All right, so let's go ahead and distribute those. This top equation, I get 5 times 4x gives me 20x. 5 times 3 is 15y equals 5 times 11 gives me 55. The second equation, 4 times negative 5 is a negative 20x. 4 times 2 is 8y. And 4 times 15 gives me 60. I'm going to go ahead and add those two together, so I eliminate my x's. 20x and a negative 20x is 0 x's. They're eliminated. 15 plus 8y gives me 23. Y equals, and I add 55 and 60, and I get 115. Now we have an equation with only y. I finish that off by dividing both sides by 23, and I find that y is equal to 5. When we take that solution back to these original equations we had, you can choose either one. Let's say I chose the first equation, 4x plus 3y equals 11. It doesn't matter which one you choose, you'll get the same answer either way. And we're going to substitute our value we found for y. So we write everything else exactly the way it is. 4x plus 3, only we replace the y with a 5. So I have 4x plus 15 is equal to 11, and I solve for x. Subtract 15 from both sides. I have 4x equals negative 4. Divide both sides by 4, and I am good. X equals negative 1. So my solution, written as an ordered pair, is negative 1, 5. Remember, x comes before y. And there is our solution.